Okay, now that we've talked about 1D a little bit, let's jump into our first example. Using the hospital data for this one hospital, there's 20 patients, and we want to compare the two groups. One is the patients that are age 55 or older, and see if they have a greater chance of getting admitted to the emergency room than the patients under 55. So let's start with that group of age 55 and older and find out their chances of being admitted to the emergency room. So to find that, first I'm going to highlight on this table all the patients that are 55 and older. So that's 1, 2, 3, 4, 5. I'm looking in this column right here for underage. 6, 7, 8, 9, 10, 11. And how, so actually before I go into, let's remember our formula for finding out that probability, finding out the proportion of those patients that went into the ER. We look at the amount over the total. So the total size of that group, the 55 and older group, is there was 11 of those patients. Now, how many of those went to the ER? Let's see. 1, 2, 3, 4. So 4 11ths of the 55 and older patients went to the ER. So that means we can make an estimation about this hospital that the probability of patients who are 55 and older have a 4 11ths probability of being admitted to the OR. Now to work with that number, I need to make that a decimal proportion. So I'm going to do some calculating. And I'll do 4 divided by 11 to convert that fraction to a decimal proportion. And I get 0.36. I'm going to round it up to 364. So I want 3 significant digits. And that fourth digit of the 6 tells me to round up. So I get 0.364. Now it's time to look at that other group. So the other group is the patients under 55. So that should be everybody else, since everybody's either 55 and older or under 55. So that's 1, 2, 3, 4, 5, 6, 7, 8. Should be a ninth. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. I miscounted. I knew it would be 9 because we had 11 patients that were 55 or older. So that leaves 9 patients that would be under 55. So now let's look at, so their amount over total. The total in that group is 9 patients. And from that group, how many of them went to the ER? So I'm looking at just the green highlights now, looking for ER. There's 1, and that's it. Just 1/9 of those. So to get that decimal proportion, I get 1 divided by 9. And my decimal proportion here is 0.111. I'm going to round down there because the fourth digit is also a 1, which is under 5. So these are how I calculate the probability for each of these groups, and I get the conditional, this is called a conditional probability or conditional proportion, because they're different groups. It's not from the total of 20. The orange one is age, or orange yellow, is only the group of 55 and older, so it's conditional of that 55 or older, so the total is 11. So that's a conditional probability. Okay, so these are the two groups. So I can convert this to 11.1%. Whoops. And I can convert this to 36.4. Whoops. 0.4%. I'm running out of space here. And the question is this significant? Yes, more patients that were older went to the ER, but is it significantly more, or is it just kind of a fluke that's going to go up and down? So the question that we need to answer is this significant? So if we were statisticians, we would have fancy tools and tests and p-values and be able to answer that more officially. But since we're just getting started, we're going to use this basic rule of thumb called the percentage ratio. The percentage ratio means I'm going to take those two percentages and find out what the ratio between them is. I'm going to put the higher percent over the lower percent. So I will absolutely get a number, percentage ratio that's 1 or higher. Since the higher, I'm putting a higher number over a lower number, it's always going to be 1 or higher. If you get a number that's less than 1, you made a mistake, and you need to flip those numbers. So we're going to put the higher over the lower. We can either do higher percent over lower percent or higher proportion over lower proportion. Just make sure that you're consistent. Either use both percentages or both proportions. So let's look back and try that again. So our information was, let's see, look at my history here. We had, history, don't go away, please. 0.364 as my higher percent. And my lower percent, proportion, I'm doing proportions, not percentages, and decimal proportions. And for my lower percent, I had 0.111. So I am going to do some division and find out what my percentage ratio is. So that's 0.364 divided by 0.111, and I get 3.2. I'm going to round that third significant digit to an 8 because the 9 tells me to round the 7 up to an 8. So I get 3.28. Is that significant? Well, the rule of thumb was if the percentage ratio, that means the higher percent over the lower percent, is greater than 2, then it is significant. So yes, this is significant. So in fact, it's so significant that it's really stating that more than 3 times the number of older groups were admitted to the hospital. That number, the rule of thumb, number 2, it means 2 times. So the percentage ratio tells you how much times the bigger one group is different from the other group. So an important note about this, what I was saying before about we chose to do decimal proportions, and I also said that you can also do the percent proportions as long as you're consistent. So if I start with a proportion for one, do proportion for the other. If I start with percent for one, do percent for the other. Because what happens if you mix it up and you do percent for one group and proportion for the other? You get a number that is, let's see, what would that number be? Let's try this one down here. If I do 36.3% divided by the decimal proportion, 0.111, I would get 327, telling me that it's 327 times more likely that the older group would get them into the ER, and that number is not correct. It's not 3.27, it's 327, so it can really throw you off by a factor of 100.